All right, my friends, let's see how you did. For this problem, if you struggled, there's a chance that it could just be a vocabulary issue. Like what on earth is an ingot? Ingot, I don't even know how to say that word. What does it mean for something to be a copper alloy? And so really it could just be a matter of vocabulary. So let's first make sure that you're okay with the vocabulary. So I think I honestly like am not super clear on what an ingot is or an ingot. Anyway, I think it's like a bar. I don't really know. Anyway, I think it's like a bar of this like metal anyway. And then if you can follow what I'm saying here, then great. Okay, anyway, so let's talk about basically the point is I don't think that word matters in this problem, but 25% copper alloy, that matters. Okay. So basically what 25% copper alloy is that you have it's a combination of copper. So 25% of this combination is copper, and then the rest of it is other metals essentially. So hopefully that makes sense. So let's talk about kind of digesting that for a second. So if you have something that's 25% copper, and then if I tell you, okay, well, you have 100 kilograms of this 25% stuff, then how much of this 100 kilograms is actually copper? So if you have 100 kilograms in volume of this 25% stuff, I hope it makes sense that only 25 kilograms of that is actually copper. So that's what you do need to understand. And whereas if you have of the 50% copper alloy, if you have 100 kilograms in volume of that stuff, 50 of that would be 50% or 50 kilograms would actually be copper. The rest is other stuff. So hopefully that makes sense. So the 50% stuff is more pure copper than the 25% stuff. Okay. All right. So now let's turn this into a system of equations. So first let's introduce variables. Well, what do we need variables for? It wants to know how many kilograms of each you need. And so I'm just going to use X and Y, I guess. So I'm going to let X equal the number of kilograms of the 25% copper alloy. And then I'm going to let Y be the number of kilograms of the 50% copper alloy. Okay. And so now I'm going to fill this table out. Okay. So first let's think about the relationship at the top here with the labels. So I hope it makes sense that if you take the amount of copper alloy that you have and add it to the amount of the other type, that's total how much you have. So let's talk about amount of copper alloy. So we're not worrying about how much is copper, we're just worrying about total volume. So we'll just say total volume. Okay, well, if we're just talking about how much of this mixture we're using, well, we're using X of the 25% stuff plus Y of the 50% stuff. And then how much altogether are we supposed to get? How much volume? Well, we're supposed to get 40 kilograms altogether. Okay, so that's my first equation in my system. It's just X plus Y equals 40. One down, one to go. But now we want to know, well, how much actual copper is in there? So how much actual copper is in there? So if you have X kilograms, I hope it makes sense, only 25% of it is actually copper. So if X is the amount of alloy, 0.25 times X would be the amount that's actually copper from that part. So, and then plus, and then if Y is the amount of the 50% copper alloy, only half of it, or 0.5 of it, is actually copper. And then altogether, you're supposed to get, how much copper is supposed to be in your mixture altogether. Well, you need to have 40 grams altogether, but you want it to be 45% copper. So that means that 0.45 of 40 would be pure copper. Okay, so the first line is for just, met at as alloy altogether, and the second line is dedicated to how much copper is in each part. Okay. All right, so now let's figure out how to do this. Let's try to do this without a calculator. So 0.25x, I would write it as 1/4 x. 0.5y is 1/2 y. And then as far as 0.45 times 40, if fractions are your friends for something like this, so 0.45 would be 45 over 100. And you're multiplying it by 40 over 1. You could just cancel stuff down. So, and then just multiply it out. So it looks like 18. There we go. Okay. All right, now we just solve the system of equations. So I like to kind of get out of the fraction situation. So I'm going to multiply row 2 by -2. Oh, how about -4? That would get rid of all my fractions. There we go. So we'd have -x minus 2y equals -72, I think. 40 plus 32, yeah. And then I'm just going to add that to row 1. X's eliminate. It'd have -y equals, what is that, -32. And then divide both sides by -1, and you get y equals 32. There we go. Okay. So, what would that mean? Like, it's easy to get here and get kind of lost, but that's why it's nice that we defined our variables, because you could seriously just take that 32 and then replace that y right there in your introduction, and it would say 32 is the number of kilograms of 50% copper alloy. Yeah, there you go. Anyway, and then the easiest way to get x, I like this little spot right there where you just knew they're supposed to add up to 40. So you could just eyeball it. X would equal 8. There we go. All right, so now we're ready. And really, if you ever get lost, just go back up to where you introduced your variables and turn that into English. So, X was the amount of kilograms of 25% copper alloy. So let's see, you need 8 kilograms of 25% copper alloy. And your Y value is 32. So 32 kilograms of 50% copper alloy. There we go. Hopefully that makes sense, my friends. That's it for notes. Hopefully the problem set goes well. And if it doesn't, hopefully you'll ask me questions about the parts that got you stuck.